if you want. Let's look at an arithmetic sequence. We did 37 in class yesterday. So let's do 38. So we'll write out the rule, the explicit rule, and the recursive rule. When you have an arithmetic sequence, you write out the arithmetic stuff twice. A sub n, first term, plus n minus 1 times your difference. I know that my 10th term is 96. That is the first term plus 9 times d. I skipped a little bit there because n is 10. Are we okay with that? Do the same thing on the other side. I know that the 33rd term is 326. Also is first term plus, what am I putting out? Very good. System of equation, which one am I going to eliminate? Subtract all that out, we get a 0. 230 is 23d. Oh no, I don't know if I can do this without a calculator. I'm not quite sure what d is. I will pause. You are. Yes, ma'am. Is it not operator error? Did you drop it? Did you not put the batteries in the right way? That was awesome. All right, so the d value is 10. What's your first term? 6 is your first term. Something plus 90 is 96. So start over. You got a sub n is your first term. 6. And you get that. Distribute out, combine like terms. Your explicit formula for this is a sub n is 10n minus 4. Okay? To go with the recursive formula, remember that just means you are working with each term that preceded it. We write it out 2 steps again. The recursive, a sub n is a sub n minus 1, and the first term is. We always put those 2 in right away. Now, with the a sub n part equals a sub n minus 1, all I have to do is tack on the difference. What's the difference here? 10. Is it a plus 10 or a minus 10? Plus 10. What's your first term? And you go on your merry way. Ayo, it's off to work we go. Yes, sir.
Now I see like an example of one of your tests, like it could be the one that you're going to give us tomorrow, but like a past one.
No.
Why?
Why do you need to see an example of the test?
So I can see what it's going to look like.
It looks like homework questions.
Are you going to give us a study guide?
You have it in your hands. I wrote it. Doesn't mean that I think it's any difficult. Let's go through a couple more examples here of things that you probably have forgotten already. Where
Because it says find a sub 39.
That's easy. You just substitute in 39 for n with the nth rule. That's all.
Okay.
Take a look here. Go to number 20. Number 20, I want to review with you guys how you set up and solve for n in both the geometric and the arithmetic sequence style. Or a series, excuse me. In number 20, they're talking about a geometric series. And what they're asking you here is find n, which means how many of these in this series would I have to add together to make it equal to 27993? Well, we were already told it's geometric, which means I have to use the geometric series formula. So which one is that? The bottom one, the one that has the r in it. Okay. So I'm going to start with writing that out. My first term, 1 minus r to the n over 1 minus r. So from here, it's a matter of filling in the blanks. I know that the sum has to equal 27993. I know that my first term is
3.
Could I also determine my rate without too much of a hassle? How do I do that? 6. So my rate is 6. So I start with 1 minus my rate to the n over 1 minus my rate. So far, so good? Okay. Why did I write 3? Sorry about that. I remember you said 18 and 3. I'm like, oh, that's 3. So now comes the fun part. I'm going to divide by 3 and multiply by -5. Good. So divide by 3 and multiply by -5. So I'm going to do this. -5 over 3. So we get -5 times 9331. 5, 5, 6, 6, 4. Is that right? That has to equal 1 minus 6 to the nth power. We're going to have to take a logarithm. I'm going to move the 6 to the nth power to the left, move the -46655 to the right. So I have 6 to the nth power is 4665
Oh, we know you'd be asked.
Yeah. I'm going to show you an example of what happens here with the negatives in a second. I think it was one of them on the homework last night. What base do I have to take a log now? 6. Log base 6 of both sides will allow us for the exponent to drop. Is it 6?
Yeah.
Yeah, but negative.
Oh, 8.
Yes, sir.
You didn't explain the. Okay. Yeah, what's the meeting last night?
What was last night?
Aren't you like coach?
Sure. Why didn't you show up? It's a root to the time. I might be recruiting because I need more
Yeah,
people.
we did together.
I'll tell you more about it later.
I think there's 3 freshmen. Oh, 3. 8th grade.
One question about these things. So basically at this point here, you understand that it takes 6 of them in this series. Now, I think in the homework there was a time where you had something like this. It was -3 to the n equaled something. It was a positive number. I think it was one of the homework problems last night.
Something like that.
I forget which one it was. I don't remember. Anyway, there was one problem where it winds up like this. It was this equals 66561 is what it is. I think that's what this works out to be. I want to explain something to you guys in terms of numeracy. Okay? What does literacy mean? Be able to read, understanding the words, understanding the vocabulary, understanding the punctuation and stuff like that. Do you agree? Numeracy is similar to that, but yet you're working with numbers. Now, here's what I want you to think about here. This is saying -3 to some power gives you a positive number. We know by rule something about that power. That power has to be what? Even. It has to be even. And why does it have to be even? Correct. Remember, that's just telling you how many of those numbers you'd be multiplying together. So if you took -3 times -3, you'd get a positive 9. -3 times -3 times -3, you get a -27. What happens here is the exponent, if it's even, it's positive. If it's odd, it's negative. If this value is negative. Does that make sense?
Yes.
So numeracy tells me that I would want to take the log base of -3 on both sides. But you can't use a negative log. So you just have to remember that no matter what you do to this problem, this n value is going to be even. So when you use your calculator, you just don't use the negative symbol. Does that make sense? I think we came across that in our notes yesterday. So if it does happen where you have your term is negative to an exponent, and it's coming out to be a positive value, think in terms of numeracy. Even exponents would generate a positive value, whereas odd exponents would generate the negative value. Does that make sense?
Yeah.
Yes, ma'am.
When it comes out to a negative number, do you change anything, or do you just pretend that?
Then, if this was a -3 to the n equals a negative something here, what would this have to be? Odd. So you just,
Erase both. Okay.
it's just kind of a little trick via numeracy that we
It
use
was
here.
like that, then you put in a +2, but it has to be odd.
Yep. Does that make sense? I wanted to make sure you guys saw that. Okay. Let's see, the other one I wanted to do. So we did the series one here. Let's do the arithmetic one. Where is it? I forgot what number it was. Let's do number, I'll do 16. Number 16. In this case here, it was also talking about an arithmetic sequence, or excuse me, arithmetic series, and they wanted you to figure out how many of them within the series would you have to add together, have it add up to equal -781. So when you're dealing with the arithmetic series, that's the top equation here. When you're dealing with the arithmetic series, it's usually a little bit more work than geometric because you still have to write out your term of a sub n, the nth rule, the explicit rule. Okay? Now, they gave you something very easy to work with. You know your first term, and you know your difference. So when you write out your nth rule, you know it's -36 plus the n minus 1 times -7. They gave you that info right off the bat. You didn't have to do systems of equations and work your way through it to figure it all out. From there, we did this in section 11 too. We distribute and combine like terms. When I distribute, I get -7n, it becomes +7 minus 29 for my nth rule. You okay with that? Now, the only reason that I needed to write that out is because knowing that when I do the series of the arithmetic, we need to have that value here. So now I go to my series notation. When I switch to the series notation, S sub n is number of terms, first term, plus nth term over 2. So we have -781. N, first term was given at -36. our nth rules when we fill in the blanks. Minus 7n minus 29 all over 2. With me on that? Okay. Now what do you do? Yep, multiply it by 2, and then what do I do with the other stuff in the parentheses? Yeah, combine like terms and distribute. Excuse me. Oh, pardon me. So if I double the negative 781, what is that? 2, 6, 1562? And in here you get, was that negative 65? So this is going to equal negative 7n squared minus 65n. What was my trick when you had to get ready to factor with these? What would you want for your leading term coefficient? No. Well, that would be the easiest way. No. Leading term coefficient, in order to use your calculator efficiently, you want it to be?
Positive.
Positive. Okay? So I'm going to add the 7n squared. I'm going to add 65 to the other side. Now be careful. This is where a lot of people make their mistake. Is this term positive or negative? Good. Don't make that mistake. So you have 7n squared minus 65n, excuse me, plus. And now I can just go right to your calculator.
Wait, instead of adding to the side, just divide everything by negative
If you do that, you still got to, you're right, you can multiply everything by negative 1. Then did you move the 1562 the other way? And you still have it being negative then? You're fine. It works the same. So at this point, you would just go to your calculator and you type in 7x squared plus 65 x minus 1562. I go right to my table. Now, is anybody's table, I need you guys to look at this, is anybody's table not going up by single values, like going up by 1 each time? Ran across this last hour, somebody's going up by like 8.
Wait, never mind.
Glad I could help. Maybe walk all the way over there.
They skipped from 64.
Okay, so now when you go to your table, what are we looking for? We're looking for 0 to be where? There it went. 11. Need 11 of them. Okay? Does it not allow you to scroll? Yeah. So you know why? Next Find it on. Gotta have that. No, you're fine. Second table.
Just the last one, that's two dots.
You're looking. Yeah, give it a minute. Not in second table. It's just 11. Yes. You okay?
Yeah, that's
The relationship between the Queen Mother,
and then the calculator.
Ice Cube, and some sad person.
It's actually a baseball player. It's like in the middle of the pitch.
I got bored too. I got bored. I can do way more.
All right. So, with the time that we have left right now, this is basically a bunch of review stuff that you guys have on here. I'll wander around, answer some questions, whatnot. Time is yours. Use it efficiently. Okay?
Thinking about that in my